Welcome back. Part 2 of Unit 9, gas laws. Sorry, it cut off. So I'm going to tell them the story that I was telling before. If you are out and about and you suddenly feel all the hair on your arm stand up, that means you're about to get hit by lightning and you need to lay down in the mud as fast as you can. I don't care if it's muddy. I don't care what's happening. You are going to lay in that mud as fast as you can, as flat as you can. Lightning goes for whatever's rounded and tallest on the horizon. And so notice how we're rounded on top and kind of tall. So this happened to me one time. I was out and it had been raining and it was lunchtime and I had a garden and I decided to go out and pick some tomatoes for lunch. I'm out in the garden getting the tomatoes. Suddenly, all the hair stood up on end and I knew that I was about to get hit by lightning. So I laid down in the mud as fast as I could. A tree, a Bradford pear, as close to me as the goggles cabinet, got hit instead of me. It exploded. There was no tree left. There was just bits of tree afterwards. I was just like, oh, I almost got hit by lightning. So just a little safety thing. You don't want to be the tallest little round thing out in a lightning storm. And this happens too with trees. It'll start to rain and people will go stand under a tree. It happened a few years ago here in Atlanta. There were kids waiting on a late bus after school to pick them up. It started raining. They went under a tree. And one guy had his keys and was tossing them. The lightning hit the tree, went down through him, killed him. The other kids were okay. So I think it was like 14 in a city of Atlanta school. It happens every year, especially to golfers. It'll start raining. They'll go stand under a tree. They're holding their lightning rod, their metal golf club in their hand. The lightning hits the tree. It goes through them. They die. So be smart about lightning, but yeah, it does make ozone. Priestley and Anton Lavoisier, I'd have to retell this story for the tape. Priestley, how he discovered oxygen is he had a bell jar. He put a mouse under it. The mouse died. He did it again with a plant, and the mouse lived. So he discovered oxygen as something given off by plants, but needed by mice. The other person who discovered oxygen was Anton Lavoisier, and he did it through chemical experiments like how we did. But the interesting thing about him is he got beheaded because of the French Revolution, and he did an experiment. They chopped off his head. His lab partner went and got his head, and he said he would blink deliberately as long as he could still think, and it was like 17 or 19 times. I know, it's gross, but for that, he is the father of chemistry, doing an experiment with his head off his body. Ah! All right, so STP, standard temperature and pressure, it's how we do the math, and it's 0 degrees Celsius and 1 atmosphere, or 273 Kelvin, or any of these things that equal an atmosphere. So STP would also be 14.7 pounds per square inch. Standard pressure would be 760 millimeters of mercury. All right. So all of this is based on, all of our gas laws is based on this idea called the kinetic molecular theory of gas. And it assumes certain things, and some of them aren't true, but we assume it so that the math works, because we're going to be doing math problems. The first one is, and this is true, that gas consists of tiny particles. They're tiny. The next idea is these particles are so small, the volume of each particle can be considered 0. Now, are they really 0? Of course not. But mathematically, we can assume that they're 0 and it's fine. It doesn't affect the math. This is about the math. The next one is these particles are in constant random motion. And that's true too. They're always moving. They collide with the container and each other, and that's what causes pressure. Pressure comes from them running into each other in the container. Now, these particles are assumed to not attract or repel each other. In reality, they probably do a little bit, but it's so little, it's insignificant, and it doesn't affect the math. Does that make sense to you? Okay, the next one is, the average kinetic energy of a gas particle is directly proportional to the Kelvin temperature of the gas. You learned that on the last test, that temperature is a measure of the average kinetic energy. Remember learning that? So you already know this, but I want to show you the symbol for proportional. It looks like this. See if I can draw it. Whoop, whoop. More fun with sound effects. It's like a circle attached to an equal. It's the symbol for proportional. I have a little story about that. When I was in college, I was taking calculus, and for some reason, my teacher hated me. I would ask a question, and she would just look at me, and then turn and keep doing what she was doing. Other people asked questions, and she would answer it, but me, she wouldn't answer my questions. And it was so intimidating and frustrating and awful. And I remember one day I was studying my calculus book, and that symbol was in it. And I was like, I hate this class. My teacher hates me, and I don't know why. And there's math symbols in here. I don't even know what they are. And I just remember having a meltdown over not knowing what that symbol means. It means proportional. Later, I found out that my teacher, her husband was also a professor there, and he was having an affair with a graduate student, his graduate student assistant. And I met her, and I went, oh, she looked more like me than my sister. And I was like, oh, it wasn't my fault. She was just taking it out on me. Obviously, she knew about the affair, and that's what was going on. So now I can have a little sympathy for her, not much, because it's still mean. It wasn't my fault. I wasn't having the affair. She didn't think it was me. It's just that looking at me made her mad about her husband. She shouldn't have been mad at me. She should have been mad at her husband. He was the cheater, pumpkin eater. All right. So anyway, that's my little thing about it. So I won't teach calculus now. Like, I'll teach all the way up through pre-calculus, but because of that experience, calculus does not spark joy in me. So Marie Kondo says I don't have to teach it. That no joy with calculus. It makes me mad when I think about it. And so all the other math classes spark joy and science, but not calculus. I will not teach it. All right, Bernoulli. So this is our last idea. It is called Bernoulli's principle. Named after Daniel Bernoulli, not principal. All right, just in case you thought. Okay, so this is the idea. When fluids, and in physics, fluids are considered gases or liquids, either one. When fluids move fast, do you think they make a high pressure or a low pressure?
Low.
Why do you think it's low?
Because storms move fast.
That's true, and storms are low pressures. It's right. They make a low pressure. You would think it would be high, but you know, science is weird, and it's usually the thing you don't think. They make a low pressure, and you know this because this is how planes fly. So let me explain it to you. So those little things that I've drawn that look like that are supposed to be flying along little gas molecules. So here we've got some gas molecules, and they have to split. Plane wings are flatter on bottom and more rounded on top. The ones that go over the top get more spread out because they have further to go. The ones that go across the bottom stay more together because they have less far to go. That causes a high pressure here, a low pressure here, and it causes lift. It's what makes planes go up. Does that make a little sense? You might have experienced this before. If you ever gotten in the shower with a shower curtain, you turn on the shower, the water is moving fast, fluid going fast, low pressure. Does the shower curtain go in on you or out into the bathroom? It goes in on you. All cold and wet and maybe yucky. It's a terrible application of Bernoulli's principle. So I have a few demonstrations for you. On the test, there will be pictures of the demonstration, and you have to match it to what it is illustrating. So there's going to be a whole series of these, and I'll have little pictures drawn on the test, and it will be what it illustrates, okay? I'm going to stop the video. Science is great, and we're going to do the demonstration.